Today I am going to show you why indexing is required in database. So this is the table. It has only two columns, ID and data. ID is auto generated and data is the normal var character type column. So here what I have done, I have inserted more than 100 millions of records in this table using this script. Let me show you how many records are in this table. So this is the code, select count star from big data. So if I execute this, it will give me count. So the table is very huge and it's more than 100 millions of records. So it is taking a lot of time to calculate how many numbers of records in this table. So you see in here 15 seconds still it is counting. Okay, it took 19 seconds to count all this record. So as you can see, it has more than 100 millions of records. So now what happened, if I go to this table and suppose I want to search this data, so all the data are in this table unique, even the data column is here. Now I have copied this data, I will paste it in here and I will now search it. For now I am not doing any indexing for this column. As you can see, there is only index for this ID, which is the primary key. So now I run this and let's see how much time it takes to find this data. 5 seconds, 6 seconds, still counting. Again I am saying is this is without indexing this column. So it took around 20 seconds. So for 100 millions of records, finding one single record, it took 20 seconds without indexing. So now if I create an index for this one, you will see the magic how fast it will retrieve the data. Create index. Let's create an index for ideas. Ideas already there. Yeah, here you can see we need for the data column, and you can do it ascending order, descending order, it doesn't matter. I'm doing it for ascending order. It will also take some time to index all those records. Let's see how long it takes. I will just speed up this video and show you when it gets completed. Okay, it is completed. It took around 3 minutes. Now let me show you the magic of indexing. Now the same record, it took 20 seconds, you can see. Now if I execute this script again, you will see it took 467 milliseconds only to find this record. I can show you the different one. Suppose if I take this one, again it will take very less time. So again I am executing this, it took 465 milliseconds. Again I am searching this same query, it took around 477 milliseconds. So this is the power of indexing. We have learned this, that we have to do indexing. We don't know how to do indexing, what is the practical use cases. Maybe you have never see the difference, how it affects our query when you do the indexing. So that's why I created this table and I put some lot of data by generating this script. You can say this is just a trailer. There's a many way we can speed up our queries. Like we can use the caching technique, we can use DB specific technique. For now this indexing technique is same for every relational database management system, but apart from that there are some other indexing features available for specific DB, for MySQL, for PostgreSQL, for SQL Server, Oracle DB. Every databases has a different techniques to index. So here you can see it took 477 milliseconds. But if we use the advanced features of DB for a particular DB, for now I am using that PostgreSQL. So if I use that, there is another feature PostgreSQL provide. We can reduce this time to less than 100 milliseconds. Those are very really advanced concept. We can do it. Suppose here I have only like 100 millions of records. Like what happen if we have like billions of records? So how do we tackle that issue? So for that we can use the sharding, we can use caching also. There is a many other techniques I will tell you in my next videos. You will get many more deep information related to software development.